Alright, hi everyone, welcome to my channel, City of Electrons, and in this video we are going to do this past question with, application of microprocessors. Okay, but of course we are dealing with microcontrollers, because that's what we have here, okay, in our labs. So let's go. Now, with the aid of the flowcharts, with the aid of flow/block diagram or diagrams, systematically discuss the development of an ESP32 based smart door lock system. Straightforward. Okay, smart door lock system that works with ESP32. Now, to understand what's going on, bear this in mind. What we are asked to do is to discuss. Is to what? Discuss. We are not asked to do the simulation. Of course, past question or exam condition, you don't have time for that simulation, so we are asked to discuss. So it's as if you are doing the actual work, but explain it the way someone can. You look at what you have explained and carry out the actual work. So that's the discussion here. So what are we discussing? Development of what? An ESP32 based smart door lock system. ESP32 based meaning the system depends on ESP32. The system is based on ESP32. ESP32 here is serving as the processor, as the processing unit for us. So, okay, so that means the ESP32, that right is here, ESP32. This is our what? Processor or processing units. Okay. Then, ESP32 base smart door lock system. We all know what a door is now. Come on guys, when door, door, okay. So smart door lock system meaning the door can open and close on its own without human intervention. That is, you don't have to hold the door and open it by yourself. The door can be opened remotely. That you can use Bluetooth or Wi-Fi to remotely control the door to make it open or close. So the opening and closing, let's say open and then close, the opening and closing of the door is the output action, is the what? So this opening and close is what? The output. Then this guy is the processing unit. This is the output action. Then what? The signal that will be sent to this processing unit, the signal that will come in, this ESP32, and it allows for Bluetooth and Wi-Fi. We can make use of Bluetooth and Wi-Fi features in ESP32. So since it allows for that, that means our inputs can be through the Bluetooth. Let me just use B for that, and then Wi-Fi. So this now will serve as our inputs. Okay, so we have input, process, and then output. This is the standard system for microcontrollers. Inputs, let me just use one letter: inputs, process, and then outputs. Okay, so this is it. Now, with that understanding, how do we carry out this thing? How do we work with this, and how do we give out this? So here we have the explanation. Okay, now this is the discussion. Okay, so the development of an ESP32 based smart door lock system is a project which allows users to remotely control the opening and locking of a door through Bluetooth and Wi-Fi, just like what I explained above here. Okay, then this project follows what? The input, process, output system, just like what I explained. For inputs, the mobile phone using what? Bluetooth, and any web-enabled device for Wi-Fi. So we have two ways to operate this system. We can either use our Wi-Fi or use Bluetooth. Then it serves as input signal. Then the ESP32 serves as the processing unit, like I said, which is suitable for this project, being that it has Bluetooth and Wi-Fi capabilities, allowing the programmer to write the program into the ESP32, so the entire system works as what's expected. Now, one thing you might want to ask or want to wonder: How come? Yes, we receive input, that's understandable. We can send through Bluetooth and Wi-Fi, that's fine. Okay. And then of course we'll write a program to receive it. Now, the how how can this control this the door from the ESP32? How can we have control over the door? There is something in between the processing unit and this door. Not actually the door, okay, not the door directly, but look at this. A servo motor serves as what? Output, which is connected to the hinge of the door, unlocking and locking when the servo motor turns from 0 degree to 90 degree. There's a device, there's a component called the servo motor. Okay, this is not a very good drawing, but it has something like this here. Okay, so base, and of course connected to the ESP32. So based on the inputs, based on the signal sent, this servo motor will rotate from 0 degree to what? 90 degrees. And based on inputs from the ESP, it will rotate from that 90 degrees back to 0 degrees. So this servo motor now, this servo motor is connected to what? The hinge of the door. Are we getting it? So when, look at this now, it's connected to the hinge of the door. Where are we? So a servo motor serves as, okay, we've read that. Let me just take that again. A servo motor serves as the output which is connected to the hinge of the door, unlocking and locking when the servo motor, okay, what was that? Unlocking and locking when the servo motor turns from 0 degree to 90 degrees and 90 to 0 degrees respectively, meaning unlocking is for 0 to 90. Locking is from what? It's from where? 90 to 0 respectively. So an LED can also be part of the output unit, serving as what? Indicator. Turning on when the door is open, as the servo motor rotates to 90 degrees, and off when the door is closed, servo motor rotates to 0 degrees. I hope you understand that. Now below is a flowchart of diagram. Yeah, so this is a flowchart of the whole thing. So it starts. Remember, for flowcharts, okay, it's just a diagram, okay, with shapes. The shapes serves as symbols indicating the flow of instructions for a program. So different shape mean different things. Okay, now the definition I just gave may not be the formal definition, but it's the basic idea of a flowchart. So this, when you see an oval shape, it's the start or end. Oval shape is for start or end. If you go down, you see end, still oval shape. Okay, now the system starts. After that, what happens is the system receive what? Signal from Bluetooth and Wi-Fi, and or Wi-Fi. Okay, Bluetooth or Wi-Fi. Now this parallelogram tells you inputs or what? Output. That's what the shape means, input or output. Then signal is sent to where? The signal is sent to the command. What am I saying? Then after the signal has been received, what happens next is what? The command will be checked. That's a decision will be taken. Sorry, a condition rather. When you see diamond, you know it's what? A condition. So checking if what? Command received, meaning did we receive any command from Bluetooth or Wi-Fi? If we did not receive, then go back to wait for the receiving of, to wait for signal to be received. Then if yes, that's command received, yes, then go down, another decision again. Door unlock command, that means the command that was received, is it for door unlock or for door lock? Okay, so if it's no, then what's going to happen? If the command is no, hello, what's here? This, excuse me guys, point. All right, better. So the arrow comes like this. Now the command received, is it for to lock the door? That is door unlock. Is it door unlock? So if it's no, That is, we are not saying you should unlock the door. No, meaning the door should be locked. That means door locked, and then the LED will be turned off. Okay, and after that one, the arrow goes either to stop, like maybe you turn off the system, or if the system is still on, it will return back to where to receive signal from Bluetooth and then Bluetooth or Wi-Fi. However, if the command is door unlock, yes, that means what? The door will be what? Unlocked. The LED will be turned on, and after that, maybe you turn off the system, or if you leave the system on, it will return back to where? To receive command. Are we together now? So that is it for the flow charts. For the block diagram, below is a block diagram of the development of an ESP32-based smart door lock system. Now, this is just showing, and the block diagram is just a diagram showing the components and how they are related. Okay, so it looks like flowchart, but flowchart has to do with more of the programming algorithm. That's the programming, while that is step-by-step instruction or step-by-step process of solving the problem or addressing the process. Let me just solving the problem or a problem. Then the block diagram just shows the components and how they are connected, how they relate. Again, this might not be the formal definition, but it gives you the idea of what it means. Block diagram. So these are the components. We have the mobile phone and we have the web. The web, of course, you can have web inside your mobile phone, of course, but we just separate them for understanding. Bluetooth, Wi-Fi. Okay. So mobile phone gives inputs to what? ESP32, which is the microcontroller. Web gives signal, of course, instructions, signal, things like that. Same thing, signal to what? ESP32. Power supply goes to ESP32. Okay. Then this ESP32 sends signal to what? The servo motor, which turns right or left. I mean, yeah, 90 degrees or 0 degrees. Then the LED also. So ESP32 send signal to both these guys. So this is just a block diagram, and that is all for this video. Okay, that's all. Now, in case you are wondering about what about the program to make that one work, now that is addressed in question 6. If you look at question 6, you will see the question in question 6. But question in question 6, it says, using a 2-column format, list the following lines of codes and their meaning. Now, looking at this code, brothers and sisters, okay, everybody. So, looking at this code, can you see this? Lock door, lock server, dot right, unlock door. Can you see these guys? Wi-Fi. Are we together? What does this tell you? ESP32 server.h Bluetooth. So this program is related to what? This one. Are we together? So
6, but it's related to the first question, like we said earlier on. So using a 2-column format, list the following lines of code and their meaning. So this is a line of code, and if you look at it, it's, like I said, referring to number 1. If you look at it, they have it's linked, brother, it's linked. So all right, so we have everything in view. Now this is the first line, which is #include wi-fi.h. What does this mean? So it includes the library to manage Wi-Fi radio function, allowing ESP32 to connect to networks or host server. That is, of course, I think we've mentioned what library is in one of our videos. We talked about the files, written functions saved in a file, and those files contain the instructions that allows a particular thing to be done. So in this case now, library to manage what? Wi-Fi radio. So instead of typing those functions again, just write the header for it, which is wi-fi.h. So that's this, and you include it. Similarly, this one includes the one for what? Bluetooth, for Bluetooth to work, for your Bluetooth to work, Bluetooth communication and things like that. So that's the one for this. These two are similar, and that also applies to this particular one also. Anything you see #include and you see .h in front, just know that they are including the library for that particular thing to work. Okay, so that's for this, and this. Okay, all the hash include. Now, this is for Wi-Fi, this is for Bluetooth, and this for what? The server motor. Okay, server motor. Now, this next line of instruction says Bluetooth serial, then serial BT. What is actually happening here? The Bluetooth serial, this one now is the class. Class is like a blueprint. Blueprint in the sense that when you, let's say you want to build a house and a structure and building or whatever, you have the blueprint. That is, this is how the thing will look like. Okay, there will be 4 rooms, and the rooms will be this height, things like that. You have it there. But that blueprint, that master plan is not the building. It's a blueprint of the building. Okay, that's how the building should look like. Then using that master plan, you can now go and really build the object. So this Bluetooth serial is the class, which is the blueprint, how Bluetooth objects, how the real thing should look like. Then here we are actually creating the real thing, which is a real Bluetooth variable we can make use of. Okay, an object of the Bluetooth class, just like saying int, then you now put 14, or you say float, you now put something point something. Int is the class, is the data type, then the 14 is the actual data. Okay, so just like this one, so we can say like data type and the actual data, class and the actual object. Class and object is the best way to look at it. Okay, so you just create an object or an object instance of Bluetooth serial class to handle data streams wirelessly. That also applies to this one. Okay, similar idea here. So initialize a web server to listen for incoming hypertext transfer protocol traffic on port 80. So this one is just like that, but when we say server 80, we are referring to port 80. In that port 80, that's where this thing is connected to. Of course, something like that kind of class and what object. But this object will be connected to where? Port 80. Okay, the default browser for web browsing. So port 80 is kind of the default browser for web browsing. Then this one is also like this first one, server, class and object. So server is a class, then lock server is the object of that one. So create a server object used to send position commands, angles to the physical motor. Okay, then of course these guys we are already used to these ones already. We are used to these ones already. Server pin, that is a variable for where this one will be, where the server motor will be connected to. So pin 14, of course it's an integer. 14 is an integer. Okay, but we don't want it to change by mistake. We don't want to mistakenly change it in the program, so we say it should be constant, constantly pin 14. The same thing applies to here, but this one is for the LED. So yeah, assign GPIO pin 26 as output for the LED. Yeah, then this particular one, assign GPIO pin 14, GPIO 14. GPIO is general purpose input and output. Okay, so that's pin 14 for the server auto. All right, then the next one, this one is the same idea, the same variable declaration, but this time this char is a what? Is a character. Because of this asterisk, char is a character. The asterisk tells you it's a string of characters, collection of character. So this. So what's happening here? It said defines the name SSID of the Wi-Fi network the ESP32 will connect to. So ESP32 should connect to what? This Wi-Fi network, but we just give it this variable name. Okay, similarly, and of course the const means that it should not change, it should remain constant. The same thing applies here, a character, but you can receive more characters, and then password, that is, this is the password now. So once you type in password, we should expect you to put, or we should expect to have this. Of course, void setup is the initial function that runs once to set up hardware and start communication protocols. Okay, so then serial.begin. Now this starts the hardware serial port for debugging output at 115,200 bits per second. That is very, very fast. So it just tells you that the rate at which the hardware should communicate should be this. Okay. Some people use 9,600, but don't worry about that. Just know that this is just for the bits per second, how many bits will be exchanged per second. Then for the log server dot attach, then server pin. Now this one links the software object. Software server is that motor that rotates from 0 degree to 90 degree, 90 degree to 0 degree. So this instruction here, it links the software server object to the physical GPIO pin defined earlier 14. So we are actually linking this GPIO pin to the hardware. That's what this instruction is meant to do. Then this one, I think we are familiar with this already. Pin mode, LED output. We are actually setting this pin what? LEDs was pin 26. We are setting this pin to do what? To be what? Output. Then for this lock door, well, it's just a custom function call to ensure that the mechanism is in a secure lock state when power is applied. Okay. Now, cool, we're almost done. So serial.begin, serial bt.begin, ESP32 lock. Now, this one sets the Bluetooth device. This one sets the Bluetooth device name, ESP32 lock, so it can be found by your phone. So in this case now, when you open your phone, okay, to check for Bluetooth network and things like that, you can see this one now. If we change this into brother, if we change it to brother lock, you will see brother lock when you on your Bluetooth. Okay, so this one just establish that one. Okay, so let me leave it at this. All right, then for Wi-Fi.begin SSD, SSID, then password, this commands the Wi-Fi radio to begin the handshake process with the router. This handshake just means they connect. Okay, that's idea of connecting. So that's the Wi-Fi. So for this one is for Bluetooth, this one is for Wi-Fi. Then for this instruction, while Wi-Fi.status not equal to WL connected, a loop, this one is a loop that what pauses code execution until the Wi-Fi connection is confirmed what successful. Okay, this one just keep the code, pause there, stop there until we have a Wi-Fi connection. Then server.begin. So this one activates the web server so it can start accepting incoming browser connection, just like as we used to do serial.begin. I think we've done that before in introduction to microprocessor. So just like we do serial.begin for the serial monitor to begin to display, so also server.begin activates the web server so it can start accepting incoming browser connections. Then for void loop, of course, this is the main execution loop that repeatedly checks for Bluetooth or Wi-Fi commands. Then if serial bt.available, now this one, for this instruction, it's a logic gate that checks if any character have been received or over the Bluetooth connection. So this one is to check, have we received anything from Bluetooth? Okay. Then char C, which is character, data type character C, serial bt.read, meaning if we have received the character, read that character from the Bluetooth and then save it inside C. So whatever character we read, we are saving it inside C. We don't know what character we are going to receive, so let's declare a variable C, but that variable is what? Data type of character. So that's what happened there. Then Wi-Fi client, then Wi-Fi client equals server.available. Now this one creates a client object if a browser has connected to the ESP32 IP address. This one saves for what? If there's something received from Bluetooth, we save here. But this one is for the what? Wi-Fi, we save here. Okay. Now if req.index of this, then open quotes / unlock close quotes is not equal to -1. What's happening there? It searches the hypertext transfer protocol request string for what? Unlock. Are we seeing it now? It's trying to look if the the user has sent anything that is unlocked to determine if the user clicks the unlock button. Now, clients.println. So this is what we have. And what does this mean? It sends a standard HTTP header to tell the browser the request was what? Successful. So what do you see here? You see OK. All right, that's to tell the browser that the request was what? Successful. Okay, now for this next line, you see clients.println. And what do you have here? Now, if you observe, what you have right here is what? Unlock. Okay, unlock. So what we actually do is to create a web link. The link will do what? It sends the unlock command back to the server when clicked. So the same thing applies to here. This, if you observe this and this, the difference is that this one is for unlock, this one is for what? Lock. So the first one creates a link, creates a web link that sends unlock command back to the server when clicked. Second one creates a web link that sends the lock. Are we seeing the difference now? Lock command back to the server when clicked. Okay, then client.stop. This one closes the connection to the browser to free up memory for the next request. And of course, lock server.write90. This one sends a pulse width modulation signal to the server to rotate to 90 degrees, physically moving the lock bolt. And of course, digital write LED pin high provides a voltage to the LED pin to turn it on as a visual unlock indicator. Okay. All right. So that's it. Okay, so that's it for it. So like, share, subscribe, comment, and in case you feel like this is a bit too fast, you can of course drop comment, leave your question, and I'll see you in the next video. Thanks for watching, and bye for now.